y equal x squared plus 3x. So to find the domain of this, you know that I can substitute any real value of x is exist for y. So therefore, you know that the domain is all real x. But the thing is, we need to find the range, because you know that this kind of graph is something look like this. So therefore, the minimum, we need to find the minimum values. So this is the point. So y is all the way from this onward. So that's a range. So to do this, we need to find the turning point. There are many ways to do it. I'm just quickly find the line of symmetry first. Now remember, x equal negative b over 2a to find the line of symmetry. So you know that is a is 1, b is 3, and then c is 0. So I find x, line of symmetry, x is negative b is 3 over 2 times 1 is 2, so it's negative 1.5 or 1.5. Then I write the y value. So when x is negative 1.5, y must equal minus 1.5 all square, and then plus 3 lots of minus 1.5, which give me 2 and negative 2 and a quarter. So therefore, your turning point or vertex, if you like, is minus 1.5 and minus 2 and a quarter. So you know that to sketch this quickly, so negative 1.5 and negative a quarter, roughly 2 and a quarter, roughly here. So negative 1.5 and negative 2 and a quarter. And then the y-intercept is 0, so it's here. It's just a quick one, okay? So you can find out the domain. That's all it is. So now the y is all the way from here upward. So the domain of this domain is all real x, and range is, see, from negative 2 and a quarter onward. So y is greater or equal minus 2 and a quarter. That's your range. So the answer for this is domain is all real x, and the range is y greater or equal to negative 2 and a quarter. How about this one here? So find the domain and range of this question. So this is same kind of question, which is parabola. We just need to find the vertex or turning point. So this one I can just quickly do by finding the vertex by completing up square. So I can do half of 8, which is 4, so which is x minus 4. If I expand this out, let's say I expand this out quickly, so x I just do on this side here, so which is x, so x minus 4 all square, which give me x square, and x times minus 4 is minus 4x, and I double give me minus ax, which is the same as this one here. But then you got 4 square, so 4 square is 16, so which is plus 16. So to make it the same, so I need to minus 16 on this side, is minus 16. So now these two are the same now. Then the 15, I just write it down. So now your final product of this is x minus 4 all square minus 1. So your vertex or turning point is 4 minus 1. To a quick sketch on this, 4 and negative 1, just roughly here. And I just do a quick sketch. Remember, I have to look for range and domain only. So I just do a quick sketch to find the vertex. See, this is here. You can see clearly 1 minus 4 minus 1. So for the y values is from this onward. Okay, this side onward. So range is this. Domain, I just write domain first. Domain of this graph is all real x. And the range for this is y is greater or equal to -1. Now finding the domain and range for this. So with these functions, which is you can see clearly x is cannot be equal to 4, because when x is 4, the denominator is 0, so you cannot divide by 0. A number divided by 0 is infinity. So which is therefore x is different from 4. So you can see that the domain is x is different from 4. Or you can say all real x except x equal to 4. To find the range, so it's just a quick recap. Remember y equal 1 over x. So your graph is this, right? This graph here. Now, this one is similar, so but minus 4. So in another word, this graph is shift 4 units to the right. So your graph is just go like this. Just like that. That's all. So you know that the domain is x cannot be equal to 4, and the range is y cannot be equal to 0. So range y is different from 0. Let's say this graph here, y is equal to x minus 2 absolute value. So to find the domain and range of this, you know that y equal absolute value of x, just say absolute value of x is, which is this one here. But this time is moved 2 to the right because minus 2. So your actual graph for that is this here. So 2 here. Now to find this value, when x is 0, y equal absolute value of -2, which is 2. So this is the green one. This is the graph for this graph here, this line here. So domain is all real x, all real x. Now for range, you can see clearly y is from 0 onward. In another word, the absolute value of any number is positive, so the minimum value is 0. So which is y greater or equal to 0. That is your range. Let's say this one here, y equal x squared minus 5 absolute value. Just add a bit of flavor, that's all. Now, if you ignore the absolute value, so which is, let's say y will be equal to x squared minus 5. Now to get this quickly, so your graph is look like this, because it's x squared is go like this way, and then minus 5 it just go down 5 units like this. See, that's all. But because the absolute value, this is -5, absolute value go 5 up, so your graph it just go this way. There you go. And then I just clear this and I redraw. So which is like that, dot dot dot, and just go like this. So this one just flip backward. There you go. So this is your graph. Sorry, I just cleared, so you know the actual graph is this way. And that is 5. Negative absolute value will give you positive. So of course this is √5. You don't need to write this down, but just to show you, sorry, √5. There you go. So the domain of this is all real x, all real x, and the range of this graph is y greater or equal to 0. Thank you so much for watching my videos.